Hello, dear students. I am Dr.Uttra Chandrawat, Associate Professor in Department of Chemistry, Government College, Kota. The topic of my e-lecture is hard and soft acids and bases. The content which will be covered in the coming lectures are theoretical basis for hardness and softness, Pearson hard and soft acid-base concept. Then we will come to acid-base strength and hardness and softness. And then finally, we will come to the application part and the limitation of this hard and soft acid-base principle. First, I would like to give you some introduction to this chapter. In the past, we talked about acids, bases and their conjugate pairs. That is, we referred about Bronsted-Lowry acid-base concept. As you know, another well-known theory, acid-base theory, is the Lewis theory, which defines an acid as an electron pair acceptor and a base as an electron pair donor. In Bronsted-Lowry acid-base concept, we learnt about strong and weak acids and bases. Now, in Lewis theory, we learn about hard and soft acids and bases. So, dear students, we should not be confused between hardness and softness and strong or weak, as these terms are completely different from each other. Strong or weak is the property related to the Bronsted-Lowry acid-base concept. On the other hand, hardness and softness refers to the property related to the Lewis acid bases. The Lewis concept unfortunately failed to provide a definite and uniform scale to measure the relative strengths of acids and bases. The Lewis definition recognizes acids and bases in terms of their ability to accept or donate electron pairs. The strength of an acid and base can be determined by the very nature of the reaction involved in a particular electron transfer process. On the basis of these phenomenological criteria suggested by Lewis, one may predict that the displacement titrations can be made the basis for much determination. For example, in the following reaction, A plus A dash B, giving out AB plus A dash. So here A dash B is converted to AB. One may predict that A is stronger than A dash. It may be said that the relative stabilities of acid-base complexes are used to express the relative strengths. From the above reaction, AB, we conclude that AB must be more stronger than A-B. So attempts have been made to correlate the different factors governing strengths from enthalpies of acid-base reactions. One of the difficulties in such determination was that with different acids or different acids or bases, different trends were observed in formation constant Kf and delta G and delta H. In spite of such difficulties to deal with the interaction of acid and bases containing elements drawn from throughout the periodic table, a qualitative correlation between various Lewis acids and bases has been achieved. In 1958, this attempt was done by Arlen, Chat and Davis by classifying the acids or bases into two general categories of class A and class B. According to them, the two categories of metal ions are as follows, which you can see on the screen. First is class A. This comprises of the metal ions which prefers to form stable complexes with the ligands having donor atoms of the first member of group 15th or group 5th, that is nitrogen, 16th starting from O, and 17th group of fluoride in the periodic table. Example of this category are alkali metals, alkali earth metals, First two transition metals in higher oxidation state, for example, iron in plus state, cobalt in plus 3, belong to the class A acids. The ligands forming most stable complexes with the metal ion of the above class A are called class A ligands. Example in this category are amine, ammonia, water and fluoride, which give preference to beryllium in plus 2 state, titanium plus 4 and cobalt plus 3 for complex formation. These ligands show the following order of preference, which you can see on the screen for complex formation with class A metal ion. Now we come to the class B. The other metal ions which prefer to form their most stable complexes with the ligands having donor atoms of the lower member of group 15th, that is phosphorus, arsenic and antimony, 16th group 16th, sulfur, selenium and tellurium, and 17th group which have chlorine, bromine and iodine in the periodic table. Lighter transition elements in lower oxidation state and heavier transition elements in such as cuprous, silver plus, mercury plus, platinum plus 2 and palladium plus 2, etc. They act as class B acids. On the basis of order of preference of complex formation with class B metal ion, ligands also can be arranged in the following order. Now you can see on the screen that the order has been reversed, which we saw for the class A metal ion. Pearson in 1963 he gave two new terms, hard and soft acids for class A and class B metal ion. In this way, we can see that metal ions of class A are hard acids, while ligands of class A, for example, ammonia and fluoride, they are hard bases. On the other side, metal ions of class B are soft acids, and the corresponding ligands of class B, for example, phosphine, iodide, etc., they are soft bases. Students, this is my first lecture, and the rest of the topics will be covered in the coming lectures. So, till then, goodbye.